Okay, so a lot of you have been here before. Some of you are new. This is AI that works, where me and Vaibhav talk about AI that works. It's a very straightforward title. My name's Dex. I'm the founder of a company called Human Layer. We help people build better, safer, more interesting, more useful agents. And Vaibhav, I'll let you do your intro.
Cool. I'm Vaibhav. I'm Vaibhav. I work on BAML. And if you don't know what BAML is, check it out. It's an interesting way to use LLMs in a way that's kind of fun. With that,
And
same
yeah,
profile.
today we're going to talk about entities and entity resolution and deduping and resolving. And I think we've got a pretty interesting kind of like it's kind of a toy use case, but I think it really demonstrates really well some of the kind of core ideas there, and will be a fun thing that you can pick up, and we'll try to keep it simple enough that you can pick it up and run with it.
This meeting is being
And put it
recorded.
in your own code, and then we will push all the code that we write today as well.
All right. So what is entity resolution? What is entity duping? And how are all these terms kind of related? I think that's the first thing I want to start with over everything else. So I'm going to screen share. I'm going to talk about entity resolution. And I realized I need my mic or my mouse for today.
All right. Well, he's getting that. Oh, he's back.
All right. So really quickly, I think a lot of people mix up entity resolution to these smaller problems to a giant problem, and that makes the problem much, much harder. So I'm going to really quickly clarify exactly what we're going to go cover and what we're going to talk about. So step one is we always have entities. So we have like some sort of name that we want to extract or some class of names that we want to pull out. So the most common example that I think everyone can relate to is, let's say, company names. I have a database of people that are registered that I know about that are legal entities of companies. And I want to say that no matter what someone says, I want to pull out that sort of data. And there's different ways that we can go about this problem. So let's take a couple sample names so we all can think about this. So someone might write the word Xbox. Someone might write the word MSFT when talking about the stock price ticker. Someone might write the word Microsoft. Someone might misspell Microsoft. And we might even have other things like Microsoft Inc. Or whatever they're called. All of these kind of map to the same entity as far as I'm concerned, assuming that I don't care about subsidiaries. I'm going to make that claim right now. And they all kind of map to this entity that I have. Specifically, this entity isn't just a plain entity. I also often have some ID attached to it in my database that is very, very specific. And what I want to be able to do is somehow get this information out. Now, there's two different problems that exist in here, and we're going to skip. And there's one last problem that we didn't mention, I guess, enriching. So in this case, we're deduping entities. So no matter what everyone says, we're going to spit out the same ID. We're resolving them to the same exact entity, and we're going to extract this data out of it. So we want to extract from whatever information the model gives us this independent process. Now, there are a couple of ways that we can go do this. We can prompt our way to trying to do this. We give it the LLM all of the companies, and we say, only use this list of companies.
Yeah, what's the naive approach to this, I guess? Like, what does that look like? Like, what are similar to like the classification problem, right?
Let's write the function signature because I think that helps. Def
Yep.
T. And we'll assume we're going to extract a single entity for now. We might have multiple, but we'll take that out. Input will be a string, and the output will be an entity type. An entity type will have a name, stir, which doesn't really matter, and some ID that is like some sort of database ID. That does matter. And the most naive way to do this is my function will also take in a list of entities. And I ask, super dumb, I just ask the LM to pick one of these. So I can write something like this, pick best choice equals ask LLM input options. And I'm certain many of us could write a prompt to go do this. This isn't that interesting. The next level of complexity that we can add is we can say, now, if best choice not in options for some sort of stir match function, or some sort of match function that we write, return none, else best, return best choice. So now we've
And
done,
this
go ahead.
and this could even be a place where you would incorporate some of those the stuff we talked about in the evals episode of like having runtime guards of like, okay, cool, we know for sure that it has to be in this list. So if it's not, we just kind of like add more error context to it and ask the LM to try again at least once.
Yeah, so we could, exactly, we could be like, oh, we could literally just do it like try again. It's like, we could put a thing here, it's like num tries equals uh int equals like 3 by default. If num tries less than greater than 0, return. We just recursively call itself, and you should do recursion, but for now. Return none. So we could do this. We could go escalate to a human. We can do all these things that we want to go do in here. But there's a couple other reasons that it might not exist. There are other reasons that it might not exist, such as like our entities array itself might be incomplete. Like imagine that in Microsoft case, great, we can scrape the S&P 500, we can get all the top businesses that we know about, and we pass them into here. But in Microsoft's case, we might actually run into an issue where, let's say someone's looking for the company human layer. Human layer probably doesn't exist in most public registries yet. And I say yet, it will in about a year or two.
Whoa, buddy, we're on Crunchbase.
That's true. But if you're on there, you might not find the right entity because it's just missing information. You might want to have an option to enrich data. So you might want to actually consider enriching your options array itself over here and then updating your options array for next time around. And the options for enriching are kind of what you said, Dexter. You could escalate to a human to go enrich it. You can escalate for another pipeline that's completely independent that scrapes the web and searches for everything around that lays and builds a list of candidates and then passes it off to a human or does it yourself. Or you can always just, sorry, one more thing. Or you can just do the thing that we did in this current code, which says we will do nothing and we'll just return none in that scenario. So there's
And it's
always,
kind of up to the caller to decide what to do if it's none.
exactly, it's your choice how much rigor you want to have on your pipeline, how much automation you add in this process. But the actual process of entity extraction, as it turns out, like this method of doing this, I find this to be a little bit easier than even this goes along. And I think actually the best way to show this is code, not even whiteboarding, because it's surprisingly very, very straightforward. So let's just go ahead into the AI that works repo. CD repos. Let's git pull just in case. Git pull dash rebase. Okay, clear. Okay. LS make their 2025 06 17 entity extraction. Let's see. Cool. UV init, and then UV add faml-py. Oops. UV you run BAML CLI test. Sorry, we do this usually ahead of time, but oh, init. All right, and
It's
then
good. This demonstrates how easy it is to do this. And while he's doing that, Derek, get a question?
Yeah, I was just gonna maybe if I could take the liberty to add like a use case in real world where I've done this kind of a TF diff and Excel as human in the loop when it didn't get
yep.
above a threshold match, which now I can see these agentified pipelines being another level. So try to take like a deterministic approach with a threshold first and then fall back to like this type of thing. Anyway, long story short was a Barnes and Noble, Digital Nook, they had like so many contracts with Adobe. And so they had a database of contracts, like 10,000 contracts they had that some of them weren't assigned to people, some they were paying and not using. And we did this process to align all of the Adobe systems, Adobe, into
Oh, nice.
basically Adobe products and Adobe consulting. And literally took like, it turned out there were 40 kind of unique like contracts under different things that weren't visible, and brought them all into those two categories. So they had a total aggregate view of their Adobe spend. They found the ones that had no owner and that they could actually save, and that like 5 or 10x paid for our project.
Nice.
So I just wanted to mention this is like type of things that you could use this, and I could give other examples.
Yeah, I think resolving something to the same shared ID is generally useful when things have many, many multitudes of inputs. It's a very, very general problem. And I think the problem that we're going to talk about today is one that should be obvious to everyone, which is like resumes. Obviously, if I have a candidate database, how many of you use some ATS system and you just want to search for the person that works at Microsoft or Amazon, like people wrote like AWS or something else that isn't really relevant, but really I just want to search for all employees of Amazon. I know when we go and hire people, we always look for people by candidate references of different companies, different backgrounds, different skill sets. Like, for example, I wrote CV engineer, but I just want to look for people that have computer vision expertise. That's going to be hard to go find unless I can do some sort of consistent entity resolution. Like skills tags are another example of where you want to do entity resolution. You want some level of entities that are well known, well established, and highly useful. And you also want to have adaptability of that. For example, in this case, boundary ML should be its own entity, but likely that a database won't have that on day zero. So I want to be able to track and amend my entities database while I go do this. And that part is the part I think that makes this problem so interesting and so fascinating. It's not merely by extracting
Cool.
entities. It's about how do you build and maintain an entity database that is changing ever so often, all the time. And I think that's the problem that we should dive into today.
Cool.
Um, well, let's look at this code. So in this case, I have something really, really simple. I have a thing that is a function I'll extract resume. It's going to extract the resume from this place, and we're just going to have experiences. But now I want to go do this. I'm going to go add some test cases really fast, just so I know, because I know that this is going to be a problem. I want this to be Microsoft, obviously. I'll put like GCP, and hopefully we'll figure out what it figures out on there. And I specifically left ambiguous. Ambiguous. So I know what it is. And now let's go play around with this. Obviously, if I go do this, it's not gonna work off the top of my head. If I just say like description, get the real company name, legal legal's name. Let's run this. And like it did some stuff. It did Alphabet Inc. It did Microsoft. And like if I spin it down to GPT-4o Mini, who knows? Maybe those will work, maybe it won't. It kind of did, but there's no guarantee. I'm really relying on the vibes of the LLM to hope that I get this correct. And I think that's the thing that we should take upskill a little bit. So let's just make this an experience data model. And I'm just going to focus on company and title. I won't even add anything else. Description. I don't need this. The legal company name. And this will kind of work, I think, but it really didn't. Like Google isn't actually a legal company name, neither is Microsoft. It's actually like Microsoft Inc. or something else. So let's make another object in here to help the model really understand what we mean. Name as verbatim. Datum from content. Legal name. Is subsidiary. Let's just know if it's a subsidiary really fast.
Mm-hmm.
And let's run this. Cool. It pulled this out. This is for Vibe resume. Let's run the other test case now, the ambiguous one, and see what it does. The ambiguous test case, you remember, has boundary ML, GCP, and Xbox. GCP, legal name, Xbox, and it's really not understanding what I want. So let's do the first thing and just like beef up the model. Really not understanding what I want either. Legal name.
I'm telling you, man, peak working hours. They make all the models dumber. It's my
That
new
might be it.
conspiracy theory.
Let's get rid of is subsidiary, and then let's ask legal name. What I want to know is, if available, best guess at the legal name of the company. And we might find that we actually
Oh,
it's interesting,
there we
right?
go.
We immediately got Microsoft Corporation, Google LLC, and Boundary ML Inc., which is not the real name. So now let's go over here. Company type, well established, well known, startup, because those are really the two established companies that I might have. So let's just go and establish this.
Oh,
And
yeah,
now,
because you kind of, and that's basically you're helping to filter between like how likely is this to be something that the model made up? Because if the model doesn't pick well known, then it's more likely that it's not in the training set, basically, right?
or owning. Exactly. And now we're noticing that's listing a Google Cloud Platform. And then we can say, we can add more. Well, let's add another one, known subsidiary, which I think is good over here. If well known. Of the owning company. So let's read my prompt really fast, what I have out here. I changed my data model. The name I still want to be verbatim from the content. Then I wanted to tell me that what company type I am. I'm either well-known, a well-known subsidiary, or a startup. And then I want to tell me in the legal name, I wanted to actually tell me if it's well-known, best guess of the legal name of the company. If it's a well-known subsidiary, best guess of the owning company. So I'm actually being very deliberate with the actual model itself. And I'm actually going to make this an optional field because in the case of a startup, I don't want to spit out a legal name. Skip if startup. So
Okay. So this is almost like forcing a very specific flavor of reasoning onto the extraction process.
exactly. And you can see now the model is actually like kind of understanding what I want to do a lot better. And it's actually spitting out what I want. Now, this is only half the battle. Because at this point, I now have something. Let's just see if GPT-4o Mini works really fast. Why not?
Right. This doesn't let you leverage your database of named entities, and it doesn't let you evolve the database over time.
Exactly. And we can see that, hey, GCP, a well-known, what's it called? Well-known subsidiary is probably not working as well. Or like GCP isn't working as well in GPT-4o
Because
Mini.
4.0 Mini still says Google Cloud Platform.
Yeah, but that's okay. We actually don't want to worry about that too much because we could spend forever prompting this, or we can have a multifaceted approach to go solve this problem.
Cool.
So let's take a look at what that approach would look like. So now what we're going to do is do something like this. Okay. Yeah, I'll put a real example in here. I'll just take this example and pass this in.
Also be interesting to see this with like the actual raw text from like a real resume rather than this little like fake markdown thing.
I'll do that in a second. I just think it's I like to use toy examples because then we don't have to all digest all the examples at first.
Yeah.
Like resume equals this. Cool. So now we have a resume. And what we're going to do now is we're actually going to go access all the experiences for company in or EXP. What is the company type? Oh, I have to set up my UV environment. UV add pydantic. Cool. This is a company type. For a company dot, let's say legal name. So I want to first get the legal name. So I'm going to do a couple of things and be like extract companies in here. So company exp. Okay. What I'm going to do over here is first I'm going to go ahead and actually get the actual type of the company. Match exp dot company type. Case. Startup. I don't really care, and I'll just like print it out, and I don't really want to do anything. I don't actually know if I have to break. I might have to. Okay. Do nothing. In fact, I might even want to do one more thing where I like specifically will set the legal name of the company explicitly to none. Because I do not want, in the case of a startup, even if the LLM hallucinates something, I'm just going to ignore it. It doesn't matter to me. It's like, it's garbage data. If it's a well-known company, I'm going to see if it has a legal name. If it doesn't have a legal name and it's a well-known company, I might figure out to do ask an LLM else. Now, if I have to go do this, now I want to do the next thing, which is validate names. Which I will do is like validate company, which I'll take in the exp.company itself, and I want to go validate this somehow. Now, what I will do over here is write a validate function. There you go. And the way I'll validate this is I'll assume that I have a list of companies, def load companies. And what this will return is this will return a list of tuples, of like name, comma, like legal name. Or like maybe what I'll do is actually something slightly different, sorry. Legal name, and then also return a list of actual descriptions about that company. So in the case of Microsoft, go ahead.
Are we going to end up doing something similar to what we did in the classification, where we kind of have a internal class that our program manages and controls the view that is like what the database sees versus what the LLM sees versus what the code sees?
Exactly. It's a very, very similar pattern, but it's slightly different. In the case of what I will be doing here is I'll say like company valid equals load companies. Valid companies equals this. And for valid company, invalid companies, I'm going to just see if the legal name of this thing that I have over here matches this. If the legal
Oh,
name
I
matches
see.
something in my database, I am good. I just
Okay,
return.
so it's almost like a group by where you have like an index from legal name to all of the known company names, basically.
Exactly. Exactly. And in the case of me not finding some valid company that I like, then what I will do after this is now I need to do ask an LLM to update, ask an LLM to update the company to find.
Yeah, you have a lot of asking LLMs in here, and they seem to be different things in different parts of the workflow.
Yeah, so I'm just writing to do comments here, but what I want to do is I'm just going to load all the companies from my database, and if I find one, it matches the legal names that I am aware of in my database, I'm good. If I'm
Yeah,
unable to find one, then what I want to do is I want to ask the LLM. So in this case, it's been a Google Cloud Platform. So I literally just dump the valid companies into my LLM and
I
ask the
see.
LLM to pick one. I basically turned this problem into a classification problem.
Why not just dump the list of valid companies in any, like at the start?
In the original prompt? Well,
Yeah,
a couple of reasons for that. And I think that's a really, really good question. Well, one of them is I can get a good bang for my buck without doing that. Like
I
most
see. You use the cheap
well-established companies.
model with a small prompt, and like a lot of times it will just get it right.
Exactly. And then if you're any reasonably sized company, your ATS of legal companies that you're going to be hiring from is going to be massive. Just
Okay.
it has to be by definition. So
Okay,
instead,
so you're just like pre-optimizing this basically, right? Like our normal advice is like use the biggest model and the biggest prompt and the most powerful thing first and then break it down when it becomes a performance bottleneck. But in this case, you're just saying like I'm gonna actually start with a smaller, tighter model and then zoom back out to a bigger model if I don't find something that kind of matches my expectations.
yes. And then one last caveat is that like I can't actually put together my actual I can't fit all the companies I know about into the prompt. I know that from the
I
get-go,
see. Yep.
right? Like we all know that from the very beginning. We can't do that. Like for this problem of extracting resumes, it's not possible. For the PDF contract problem, It's not possible to put all the contracts into
I
the
see.
system. Most problems that have an entity resolution problem can't do this on day
You
one.
can't just put it all in a prompt. That's
Yeah.
actually a much better answer.
Yeah. So like it's kind of it'd be wasteful for me to go even write the base prompt because
Yeah.
I know up front by definition of the problem I can't do it.
Cool. And
So
so
what
I
I
imagine
do
there's some stage where we kind of like if we do want to push them in, we would narrow down the set that we pass into the LLM
exactly,
somehow.
and that's literally what we do over here. We do the
Okay.
same thing that we did in the classification problem. This is a classification problem.
Cool.
Right,
Okay.
at this point, because all I'm doing is I'm taking the legal name of the company, like Google Cloud Platform, and trying to classify it against the known companies. And we all know how to do classification problems. There's many
Yeah.
different approaches. One example is we just dump all the companies into there. Another
Yeah.
example is we go
You
ahead
do
and
embeddings against
do
it and
embeddings and go do the whole thing. So it's really up to
cool.
us how we go about this problem, but this basically becomes a classification problem at this point. And in the case, the only difference is now I'm allowed to return other or like no company found. And if I find no company found, then I have a choice of what I do at this point. So this
Okay,
function,
so we're actually gonna kind of like skip over that classification part and just zoom out and look at the bigger, broader pipeline, right?
exactly, because there's no
Okay,
point in
cool.
rewriting that process again. I think if someone is interested, they can go look at the classification video we did a couple weeks back and just know
We will
what.
put a link to that in the show notes.
Yeah. But like once you do the classification, refer to video. Um, Once you do that, then you're basically able to go move on. Now you have a valid company. Now the problem is this won't always return a valid company. Sometimes it'll return something not found. So we want to go update this and make this a little bit better for ourselves. So sometimes we'll return this, otherwise we'll return none. For now, very simplistic case.
Mm-hmm.
Now what we want to do over here is, I need to enumerate this. If result equals this, if result is none, if the result is none, then I kind of want to invalidate the company and mark it as such. Otherwise, I'm okay leaving it as that. I kind of want to say this legal name is not valid. So even
Because
if
the
it
legal
was
name
public,
is what you're going to use to map. That's like you're using that as a proxy to the database ID, basically.
exactly,
Okay.
exactly. I'm using this as a database ID. So if I'm unable to find a valid company for this legal name, I'm going to go and like just not care about it. If I am able to find a valid legal name, then I'll go do this. And in this classification problem, what I do is like I'd call an LLM. If it found a valid legal name, I would just change the legal name of the object that I have and return it back.
Cool.
Cool. So now I have this. I'm able to go do this. Now there's a couple scenarios in here that all fail. Same with the legal name over here. This is also like classified. So like let me just write a function really fast. Class pick potential name company. Content stir. And what this will return is like a stir or none pass.
So
And
what is
it's
the content that gets passed in there?
exactly. So what I would do is I'd pass into here, potential company.name.legal name. So I pass in the legal name of the company and ask it that if return company.legal name equals potential company, return company. So this is what I
I
would
think
do.
I keep getting tripped up by the tuples. Are you down to put a couple like actual examples in there
Let
instead
me
of
put
like the names of the
yeah,
columns?
that's a good idea. Microsoft Corporation, Xbox, Xbox, Azure, MSFT, and maybe there should be a dictionary. Maybe that'll be easier.
Sure.
There we go. Cool. Google does not own GitHub. This is like one example of companies. Sorry about that. Good call on that. Company items. Valid company. Cool. There we go. Cool. All right. So now what I would do is I just pass in the legal name. I pick the potential company. And what I can do over here is like for legal name and how many. And I just return this. So now I'm doing something very, very simple, which is I just see if any of the aliases match. the content. And if they do, then I'll return the legal name. This could be an LLM function, but I'm choosing to use a very basic heuristic here instead. Does that make sense, Dexter?
Yeah. So this content is really like a company name.
Yeah, which one? This
So I
one?
mean, we use
Depends.
content in the main function, and in that case, content is like the source of the resume. I don't want to mix up those
But we're
variable
going to do something
names.
over here. So in this
Okay.
scenario where the legal name wasn't provided for a company, then we're going
Yeah.
to do this. Potential.
But it's not the full resume, it's the company.name.
Exactly. So if the legal name is none, I'm going to pick a potential company by passing in the legal name.
So I guess my point was like in pick potential company, should that variable be called company name
Uh, it's
rather
not
than
always
content?
going to be the company name because in different
Okay.
places I'm passing different things. In the
Okay.
valid where I have a valid company, I'm going to pass in the legal name. In the
I see.
case of where the legal name was not filled out by the LLM, I'm going to pass in the actual name of the company verbatim from the resume.
Okay.
Using different things to go do this. And you can imagine that I pass in like different piece of content. I might pass in the whole experience block into here. It's really
Okay.
up to me as a developer to decide what I want to go do. But the
Cool.
goal of this function is to say, given some string, tell me all the relevant pieces of content that might match that company. And if I have it, then I update my company name into here. Now, the nice thing that I'm able to do about all this is I'm also invalidating names that come back to me from the LM. If the LM gives me a name, I'm invalidating it if it's not valid. In addition to that, I also am going to go ahead and do the same thing with subsidiaries. I'll do the exact same thing. So I'll just like put this over here. Oh, I can't do that in Python. I didn't know that. Okay.
You might be able to use an or something.
Oh, maybe. Oh, I can. Nice. I didn't know that. Cool. Match is pretty freaking cool. So now I can actually go do this and I can handle the scenario really nicely. Now I can build a, now that I've done this, I basically have a pipeline that is able to go ahead and validate all sorts of things in here. Let's go run this really fast. Clear. I'm actually going to make the problem a little bit simpler and change what model I use to be a very, very bad model. Oh, llama P4 latest. I don't know if this will work, but it might. Oh, ls uv run python -m hello. There we go. So I'm gonna go run this with an Olama model really fast and see what happens. My Olama might not be up. Oops. There we go.
There
Okay.
you go. Something happened.
So the model, oh, I forgot to print out stuff. That's funny. Let's go ahead and go print this out. Print. There you go. That's what I wanted. And I'm also going to print out the response ahead of time. Before and then after enriching. After. Okay. And then bama log equals. Oh. Oh, this can't actually happen. That's cool. Python yells at me. So now we can see what happens before. So before we have Boundary ML, null, the Google Cloud Platform subsidiary of Alphabet. And then this thing did actually not do this. I might have to debug this a little bit really fast. This thing did not get enriched. Let's see what happened. Well-known subsidiary should have gone into here, exp.company name. Let me print this out.
Maybe you could just tell cursor agent to add a bunch of print statements.
That's probably true. Add some debug print statements. Okay, what does this? Did it, will it do command KI? This is the only problem with AI generated code. It takes a while to write. Let's just go for it.
Beautiful.
We're gonna have a lot of print statements.
Have you ever used the cursor debugger that lets you like step through Python code?
No, I haven't.
It's sometimes pretty good.
Company type of startup. Did I make something silly and not actually go through every company? Oh, I see. I didn't know Python. This break actually breaks out of the loop.
Out of the loop, yeah.
Yeah.
I don't think you want that.
Okay, let's get rid of more debug statements. Now we'll go run this. So now when we're able to go do this, in theory, this should null out the actual legal name of the GCP because it didn't actually work.
Okay, so this is just detecting which ones can you accurately extract. This is, and then after that, you could do another pass to go try to ask an LLM to better pick or do a lookup or do a RAG against the list or something like that.
Exactly. And now we can actually go further and say if the result is none, what I can say is like other names equals pick potential. Sorry, let's go to validate company. What I can say here is if this is none, what I also want to do is another option from name equals pick. And then I just return this. So if the actual legal name doesn't find it, then I'll also try from the original name that I got from the LLM when I'm validating a company. And we'll see what this does. So the goal here is to say that there are many ways that I could enrich it. And you can see right over here, I was able to enrich it to Google now. Because what I said was, oh, even if the LLM doesn't initially get a good legal name, which it did not, it got Google Cloud Platform. What I will do is I will go ahead and try and find a good match. If I am unable to find a good match from the legal name, I'll try the original name in my database and see if I can go find it.
So you see, we're going to go check, does the original name match one of the aliases, basically?
Exactly, match one of the aliases. And this is, again, the most simplistic algorithm that I could implement here. I could do something more sophisticated here, such as calling an LLM, asking another model to go say things, or go do something. But now, this is still only half of the battle. I'm still not done yet because we have Boundary ML. Boundary ML is clearly not going to be found in my database. So what I need to do is I almost need to build a totally separate workflow to solve for that problem. And the best way
and you could almost do something agentic. I want to hear what you're going to say, but I was like, you can almost do something agentic here where it's like there's a LLM is picking a tool that is like actually the next step is to update our list of companies because of some input or some human input or whatever it is.
Yeah, I may not even need like really. I might just know that, hey, if it's a startup, I always need to do an agentic workflow. And I might want to maintain my list of startups separately than my list of well-known companies, or even mark these as startups versus well-known companies. So then what I could do now is like build a database pipeline that says, as soon as I save a data into there, I push something to an SQS queue that says, go look up information about Boundary ML. And here's database IDs that could be impacted by Boundary ML. So if you find a company called Boundary ML in the cloud somewhere, so let's go back to our whiteboard. Where'd it go? So now the next step, now that we have this pipeline where we're pretty good about legally known companies that we have in our database, now we have a separate thing. Now what we're going to do is we're going to create an AWS SQS queue that's going to do a couple of things. It's going to submit a job that says, look for info on Boundary ML. Also, by the way, the row ID that I just inserted is equal to like 51. And
So your goal is basically you're gonna put in what you extracted, and then you're gonna say like, hey, we need to get a legal name for this company.
Exactly. So I'm gonna give it the information that I attracted. I might even give it the raw resume, something else that I might want to give it just to give it more context on it. I might want to give it the full resume, the original text or whatever I have. But specifically, I'm gonna tell it I care about this company, Boundary ML, in this resume. So now I can build a pipeline whose job it is to first say, give me everything, every clue from the resume about Boundary ML. Oops. And this becomes, again, a very simple prompt that we can go do. Now I can use web search or some other tool that I want to go find all the relevant information. Then I can build a whole. Go ahead.
Okay, so you would use those clues you extracted from the resume to build good web searches, basically. It was
Basically,
like
that's what
if
we're
you
gonna
didn't
do.
know Boundary ML was an AI dev tools company, maybe you could figure that out from the resume, and then you would search for BAML AI instead of searching just BAML and getting a bunch of things about Bank of America.
Exactly. Or I might have the location of the person and where they live on, or go do something like that. I might find all sorts of clues that might give me information about that. Then you can make a
Hmm.
bunch of search queries, build a web search pipeline, and at some point, this thing will end and it'll put together a proposal. Or it'll put together no proposal. It's really up to you. And now that we have a proposal, we have our list of databases. This becomes an entry into there with a status of proposed instead of committed. And it is some other agent's job to migrate us from proposed to committed. Now I
And that
say
might be human input, that might be more searches against the database. You decide the logic for what lets you commit a new entity to the database.
exactly information, right? If you're doing this for tax information, you want to probably have a human in the loop. If you're doing this for like resume ATS information, it's just like small enrichment for like making searches better. Automate that sucker. It doesn't matter. You might even want to go straight to committed in that scenario. It's up to you.
Right. I mean, it's also like there's two kinds of human in the loop, right? There's human in the loop, like, do not commit this until someone has reviewed it. And then there's
Yeah,
like, commit it, and then anyone has the ability to come back later and edit it and update it, right?
exactly. Exactly. And we can just email our Slack channel saying we added a new company. Go review it whenever you have time.
Yeah. All that
Um,
async or batch human in the loop.
exactly. And all of this whole thing just becomes like a workflow that we've built out. And now we have this other last piece of information, which is row ID 51. Once it becomes committed, what I need to do is I need to go to the other database where I've stored this information. And then
Right, because you have two tables. You have tables of like your abstractions, your extractions that are like in progress or pending, and then you have the lookup table of all the companies you know.
exactly. And now update row 51 for boundary amount. That's it. Once that is committed. And now we've actually built a pipeline in a fully automated way, or as automated as this process is for proposed to committed, that can go find information, do web search, and then go figure this out. Before we go into the next part of it, any questions from anyone? You can type in the chat or raise your hand and come on.
I guess my question is like, is there a zooming out here bigger? Like, is there like what else is here?
Honestly, this is it. I've seen this work a couple of places for a different couple of different companies. This works for all sorts of processes. So like another process that doesn't sound the same but is exactly the same is topic clustering. So if you think about what topic clustering is, let's say I want to have like the most semantic, let's say I'm building like a giant news media company and I want to know what topics are sensational in the world that I should talk about right now. That's basically the same pipeline. I have a bunch of data
Because
that
a
I'm
topic
extracting.
is an entity with
The
like an
topic is an
official
entity.
thing.
Exactly.
What if I was
Exactly.
making a tool to like label all my Gmails for me?
It's same thing. I want to go do the same thing. And go do that. So you don't have to really think about any of those concepts because those labels are entities and you don't want to make new labels all the time. You want to resolve them to the same labels whenever possible. And
We
you
got a
can
question.
also
Sorry, go ahead.
and you can also do interesting things with like not just labels, but also with hierarchical labels. So you can have like topics that are like saying like we want to go up, down, and you can go figure that out along the way. So it's like, do I want the higher level category or the lower level category? It's up to me. And all of that is almost the same problem. So in the case like news media, I might want to say like have global news and have like Britain news or like US news. And those could be hierarchical designed, or where I look for global news first and then I find the subcategories around it that are around like environmental stuff or environmental stuff or like financial news under global news, or I can go straight to financial news or global news or financial stuff or environmental notes along the way.
Yeah, the multi-entity grouping is kind of tricky where something could have multiple different categories and like it's one of n instead of exactly one company.
Then you just return an array. And it's the
And
same
then you
exact
can run through the same validation checks on each
exactly.
thing in the array.
Exactly. If we're doing multi-label thing, it's actually really easy. All we do is let's go do this really fast. I'm gonna turn on my Python type checker so we can see how we actually catch these bugs. Uh, oh, let's add this in here. Sorry, static analysis is very important to me. So now that we go down here, let's go ahead and like add this in our way. So what do I do over here? Well, maybe there are multiple legal names that make sense. So let's
Right.
make this an array.
Let's
And
pretend you
now,
worked at Palantir and you consulted for 6 companies, but it was one experience.
exactly. Now what I have to do here is this will return instead of a string. I mean, this can still return a string because this is just like for content. Legal name, company.legal name.
We have a bunch of questions stacking up, by the way.
Oh, sorry.
No, you're good. You're good. I didn't want to interrupt you. So I just wanted you, if you're,
Let me do this one.
let's see.
All we have to do here is now we just make this a for loop. And we have to do the same kind of code wrapping to make this a for loop. And then we might want to resolve the same. If the for loop for some reason dumped out like GCP, Google Cloud Platform, we want to resolve them both to one entry called Google. That's the only other thing that you'd have to do.
Oh, and then you end up flattening the list.
Exactly.
Then.
He doesn't flatten the list. Exactly. That's all that ends up being.
Cool. Cool. Can BAML use lower level models like BERT or Alberta?
Right now we have just LLM support, but you can, if you wrap BERT or Alberta around an LLM API, which I don't think you can because they're just embedding models really. Yeah, then for now no, but eventually yeah.
Yeah, Michaela has a really cool example of like if the BAML run didn't return like null for one of the fields, they would go do a web search with Tavily and then just pass that context in.
It sounds like they naturally discovered the same process that we just discovered today, which is like if you got an empty field, which is in this case got this data out of here, you just run web search and do the same thing again. That's kind of cool.
Yep. Okay, when does the database pipeline get triggered? Right after the ML pipeline, or was that from one of the BAML functions?
Oh, the database pipeline would get triggered right over here. So what I can do now is I can say like, at the very end of the code, let's actually write that out.
Yeah, it's like, yeah, exactly. It's like
you
you exit the loop, you've done all the repairs you can, then you find the ones that didn't get satisfied and you go kick off jobs, right?
Exactly. Is none, then I just kick off a job. Is none. Print kick off AWS. Click off job to find better match. So now I can go do this. And this is when I would go do this at the very, very end of this.
Cool. Proposed to committed is a bit vague. You're updating data in a database in prod for the company info search results, but AI could commit on wrongful information. Yeah, so that's what we talked about. Is like you need to look at your risk and your use case, and you may want to have kind of human in the loop, or you may want to have it push it to like a staged database that gets reviewed regularly and that gets queried.
Exactly. You can view your SQL table for this company information table to look something like this. Like you have like a table called like company name, company like ID, company attributes, like other keywords or something that you might want to have about it.
You could have
keyword.
I guess like you could have a flag that like whether it was human reviewed or like how hard committed it was, right?
And then you'd basically have like company.status. Company.status. And status would be one of proposed ready.
Yeah.
And when
And you
you
could even store the like human comment or whatever it is.
yeah,
And you could
that's
actually
the
asynchronously go through with an LLM and try to repair this. Like if a human said, no, that's wrong, like go search for this, that you could kick off new jobs periodically based on
exactly.
that.
It's really important that your data model represent the complexity of your problem. So if you need multiple drafts of a company before you can get to a good resolution, you need a data model that can go do that. And this is independent of an LLM. Like this is even like if in Wikipedia, for example, they keep track of every edit that every human makes so they can roll them back really easily. That's what we do with Git. You just need to find the right data model that represents the complexity of your task. So in this case, I did something very, very basic where I only have two Booleans, proposed and ready. And I can make a web UI that literally shows everyone on my company internal dashboards a view of these tables, and people can manually promote. And I can have like a last updated column on top of here is like last updated that I sort by. So in the UI, people can go see this. And I can have information about who the last person that updated was, or I can do what Dexter says and keep a full edit log of the entire edit history of that row and go make that possible as well. It's up to me as the developer of this application to decide the requirements for this task.
And this is what we always say is it's mostly engineering. If you can do the software engineering behind this, you can build the tool that fits your problem and it's going to work a lot better than one of these like one size fits all, just like rag against a thing and push it in and hope it works.
Yes. Does that answer your question?
Sure.
Perfect.
Yes, very cool. I really like Sean's question. I'm wondering if you'd be down to come off mute and kind of clarify a little bit more what you're thinking about. How do I think about performances of large numbers of these matches? I guess for if you're going to classify emails, you could have 10,000 plus calls.
Yeah, can you hear me? Okay.
Yes.
Yep.
I'm actually on the train at the moment. So the yeah, there's that N+1 thing. If I have lots of emails, I wanna, maybe I would think about batching them, or training smaller models on my custom task, would be how I'd want to do it in production potentially, if I have lots of similarly structured documents. So I'm just kind of curious your general philosophy on using LLMs in your BAML framework, and like, am I just kind of being old school and worrying about that, or just do the API calls and move on, or should I
Well,
be thinking about something else here? Yeah,
well, just as I think we say a lot of times, like this LLM stuff is pretty much just functions. So in this case, we have like a type signature. The thing that implements this type signature could be a really, really complicated model like O4 that we toss at it. It could be GPT-26, who knows? It could be a very tiny model that we've custom trained to actually take a specific content and then spit out the actual company that we have trained on. It can only output valid companies, nothing else. It could be a really, really cheap heuristic like the one I wrote here that just matches on aliases. So that becomes your prerogative. But the most important thing is you just need to collect data on what makes this function really good, what makes this type signature perform accurately. So once you have large scales of problems, there's different ways when you use the word performance. If you're thinking about speed and cost and latency, then yeah, the answer is try not to use an LLM, write a really dumb heuristic. Now, the problem is this heuristic might not balance very well for accuracy, so you might need to use a bigger model. So then you try a GPT, try like the 5.4 models like I was trying right now. And if that doesn't work, then bump it up to 0.4 because so you can just ship the prod and not have to write 5,000 lines of code trying to optimize your model away. And then collect data, use that data to go train a tiny model, eval it against your system by having a benchmark, because this system can be benchmarked with an F1 score. So we can get a numerical benchmark on this and then just run that in a loop until you have a type signature that meets the constraints of your problem. But it's really about thinking of it as type signatures. And once you think of it that way, then you choose what part of the system you want to optimize as a developer. Does that answer
yeah,
the question?
yeah, I love that. It's a very compelling part of the whole stack. The kind of last little follow-up is a lot of my natural language.
You're gonna have to type that out. Your audio is cutting out.
Processing has like an span step and then an entity linking step, and you're kind of doing it as a one-shot sort of thing here.
Okay, I'll let him type it out while he goes and does it. Dexter, is that kind of how you think about optimization as well?
Yeah, I mean, I think that tracks. I mean, I'm still always all about this, like, use the it's like what we did on the policy to prompts episode, right? It's like take a subset, work through, iterate on a small subset of 100, and then move up to 1,000 and understand the performance. And like at the end of the day, yes, if you want AI to do the work, then like you're gonna have to spend the tokens to go do the work on all the things. But like iterate and get it tight on a small subset, figure out, learn what you can do with smaller models before you like 10x the number of records you're processing on each run.
Yeah, I agree. I agree. I think that's the general philosophy as well. While we wait for Sean's question, if anyone else has more questions, feel free to type them out in the chat. I'm going to show you how to do some of the enrichment tasks that we had like hand waved away, if that's useful. Function, extract, company clues, resume string, content, company, target, company string. Okay. Given this resume, tell me all the clues that may help me find information about the company, target company.
Yeah. Or you could even just have it output like queries for web search.
So I will do that in a second, but I'm going to go break
Yeah.
this up.
Cool.
So I'm going to go run this in a very, very basic format. And like, let's go do this. Company clues, resume, target company, boundary ML. And what's interesting about this is because I know that extract company clues will only ever be run on like large, smaller companies, I build my test cases like that accordingly as well. I don't actually build my test case to have Google. I don't care because the input to this function is guaranteed by my software layer, by the API definition I have of how I'm using this function, that the scope is only ever going to be unknown companies. Now that scope can change, like in regular software, your function can suddenly be used for concepts that they're not used to. And you just have to keep that in mind. So you might want to drop a comment to let people know. But let's go run this and see what it does.
Yep.
So it's giving me a bunch of clues. This is not very good. Let's go do this and go do this here. Class. The clues, clues, string array, good searches, good Google searches, string array. Let's change the data type here to be a little bit better. And I'm doing this in one shot. And that's kind of interesting over here. So now it's like, and it's interesting. It actually says, oh, it might, Boundary ML might be doing computer vision stuff. It might be C++ and Rust might be parts of Boundary ML stack. And now you can, it actually gives me pretty good information about how to go find this.
What is your target company? Okay, so it's still asking about the other things. Interesting.
Well, it might, because that might still be a good search in terms of what it is. So let's make this better. Because I think you're getting ambiguity on here. Class search. Priority. I may low. Based on which queries I should run first.
No, cool. And then you can do like a group by and run them in batches.
Exactly. Then I just run all my queries that are high first. And like, this is probably a good query. Vaibhav Gupta Foundry Founder ML. That'll probably get you a legal name of a company. Startup founded, and it's just like helping you go do this. And like I would go just build now we can imagine how to build a pipeline off
And
of
you can
this.
go iterate on that prompt and test this and be like, oh, hey, you're a expert researcher or whatever prompt tricks you want to use.
Exactly. And then you can
Cool.
toss web search at it. You can do whatever you want, and you can find information about this. Tell me clues that may help me find information. Specifically, I want to find the legal name of the company. And I can like prompt my way through this and just see what it does. And now you can see that the queries got a lot better. And it's actually really funny what the queries are doing. It's actually giving me like search queries of like who is patterns and like actually really restricting this to this. And it's like looking for my name in like quotes because it knows Google will search for this specifically.
Oh man. I almost want to give you my Exa API key and have you run some of these.
Yeah. So this is basically what we would end up building. We'd go build this out, then we'd actually go build the search part of it, and then we'd pull the data out. We build an agent to evaluate the results of the web search to see if we basically write a function that says extract legal name. Function extract legal name from like content.
And like search results.
Exactly. And just pull that out. And then I'd go do this. And I just go do this over and over again until I have a good legal name.
Cool. And you could have it output like 6 and then have a model do the judge thing and pick 1 or 2 or 3 of the best ones and then send 3 of them to a human in Slack and be like, pick which one is the best and kind of all that kind of
Exactly.
stuff.
All this basically just becomes software. That's the point.
Yep.
Because all we're doing is we're just designing like API contracts that have some guaranteed data model. And now we know how to go deal with this data model in one way. And like, for example, like you naturally being like a systems engineer, you went to being like, oh, I'll just run all the high ones in batch parallel. Someone might not do that. They may do everything sequentially. They may write all of them in parallel. It doesn't matter. It's up to you as the engineer to decide the trade-offs that you want to make and the amount of system resources you want to spend to find the answer. Let's take Sean's question really fast. Normally I do entity linking as a 2-step process with an entity reference as a span and then a link. But then I realized it's more of a comment than a question. Yeah, so I see what you're saying. Cool. Yeah, the span is kind of the only problem that I've seen with the span is sometimes the model, if you like use URLs, we discussed this last time in our prompt hacking thing, a model is just less likely to actually dump out a URL correctly. So I would just recommend swapping out the URL with some indexed ID. So instead of having the model dump out like HTTPS google.com like this. Oops. Like this query is just going to be way worse than having the model spit out like Google search ID X0. Like there's just way less tokens and way fewer things will go wrong, especially once the URLs have like something like ref equals like once you get to these things where things aren't really mattering, your tokens get completely screwed and hard to go extract. So you want to be really careful about what strings you have the model actually spit out. And you want to reduce the noise or like entropy of those strings to be as stable as possible. And we discussed that last week. We had a really fun time discussing all sorts of techniques. Are you on team beef up models as you dev, or team weaken down models as you dev? Personally, I'm on team of use the best model possible initially because shipping your product is way more important than cost in the very beginning, unless you know for sure you have cost constraints. I personally use the maximum amount of resources that I can for a given project without optimization in the very beginning. Dex, what about you?
I like to use big models first and then pare it down. It depends on the question. It's the same thing with developing agents too. Like the 12 factor agent stuff is all about like, hey, let's get right in the weeds and make things really, really good and engineer everything. Like if you can just give a model 10 tools and a prompt and it can get it right for every single use case that you care about, then do that. And then when you find the things it can't get right, that's when you start decomposing and engineering.
Exactly. Or like in our case today, we knew for sure that it's impossible for us to dump all the legal companies into the problem. So we're not going to waste our time doing that because it's not in the constraints of our problem. So we'll start
Right.
with the minimum amount of work that we can. But you'll
You still
notice
need to know where the walls of the box are and know like, oh yeah, I'll never, no matter how big the model is, this is just never going to yield good results. So we're going to skip trying to do that.
But you'll notice that I did not write an LLM prompt for validate company, pick potential company. I just did the dumb thing where I just use aliases. And it might work, to be completely honest. A lot of resumes probably use like 1 of 50 words to mention a company. I may not need an LLM for this, but I might want to use an LLM anyway, because it's faster. I think one of our engineers had a really, really funny thing recently where they mentioned that we don't actually want to do like a standard library. Like languages might not need a standard library anymore because technically everything can be an LLM function. Actually, I'll show his expose. And I think that was better, Antonio, because I thought this was very, very funny. He talked about how when you're actually doing you could technically do URL encoding using an LLM instead of actually using string interpolation and format strings. And this becomes really interesting behavior in the future as we as developers can go out. And right now, this looks extremely silly because we all know how to do URL encoding with just like string interpolation. But this might not be as crazy as it sounds anymore, like 5 years from now. Just like Slack using 70 gigs of RAM would have been insane 10 years ago, 20 years ago. And now it's like, it's okay. Every laptop's got enough. We just go spend the RAM. It might be true for compute as well.
I love it.
Anything else before we close out? Going once, going twice. All right. Well, today we covered entity extraction. Thank you guys for joining us. Next week, I think is going to be really fun. Dex, do you want to give them a preview of what we're talking about?
Yeah, so I dropped the link in there. So we do a lot of work on this show, but we also do a lot of riffing. And our favorite thing is to get on and talk with you about your real problems. And the things that we don't like doing as much is downloading videos and creating transcripts and writing up notes and things like that. And so we're gonna get all the boring stuff set up ahead of time, but we want to walk through kind of building live a AI content pipeline where you can take a video like this, whether it's sessions that we're doing, whether it's a video you find online, whether it's a meeting you have with the customer, whatever it is, like take recorded content and turn it into a content pipeline of like a small blog post, uploading the events in GitHub, pulling out the transcript, and kind of just like doing as much as we can get done in an hour of like how we run the show in the background and how we use AI to kind of make it better and how we come here and talk about all these like toy problems. So next week we're going to solve a real problem.
Cool. We're gonna be fun.
I have a quick question, if you don't mind, if you have just a few seconds. For